I'm not used to a microphone, so this is going to be interesting. Can I skip past this one and do my slides? Yep.
Yeah, of course.
Terrific. If I could see the timer, that would be
that would be useful.
Okay. Okay, so for starters, I'm not an AI expert, which might be a bit weird given the title of this, but what I wanted to share is how I've learned different types of artificial intelligence just through play and experimentation, which is something I think is really important and we should all be doing more of. And I'll be doing that through some takeaways, but also sharing some fun side projects that I've done. So this is me. I'm Developer Relations Lead at Avanade. I'm a Microsoft MVP in mixed reality and developer technologies. I'm also a published author in augmented reality development and doing a part-time master's in entrepreneurship and innovation. So yeah, that's me. So just like Liam Neeson, I have many skills, but none of them are being able to rescue my kidnapped daughter. They're mainly on like a technical side. So, but most of these skills I've learned from mobile and Windows development, VR, AR. I've not actually led or picked up in my day role. These have all been on side projects and side of desk things. And I think this is really important to try and build out that skill set if you can. There's a few themes going to cover in this talk. We're going to be talking about playing and experimenting and the importance of having fun and enjoying the process, because that's how you're going to learn better, and how if you're playing, experimenting and having fun in that learning journey, that is how an innovation happens. That's the best type of innovation in my opinion. Like I said, we're going to cover some side projects where I've tried different types of artificial intelligence to learn how they work. You'll notice they're usually a bit fun and silly. That is just how I learn. I have to make it fun and interesting and then apply it to more serious case scenarios. But we're going to rewind a few years first, back to our early childhood if you can. Because as children, we have this built-in innate sense of curiosity about the world, how it works. We like to use our imagination and exploring, but then something awful happens as we grow older and we enter the workplace and formal education. We're told to stop doing that, do it this way, focus, pay attention. And I think that is really something that stops our development of our imagination and our innovation until later years. So my first takeaway is please don't stop daydreaming. Try and carry on through life with that playful, childlike curiosity of the world for as long as you can. So I don't trigger any scientists in the audience. When I say experimentation, I'm talking like informal experimentation. But most of my experiments and side projects and play starts with, well, wouldn't it be cool if I could have a rotating globe in my living room in augmented reality, or how does this work? And that's kind of like the hypothesis and then the analysis. And then once I've done that and learned how the technology works, you then try and apply it in different ways, the different components and different combinations. And that's a lot like the synthesis. So that's what I mean by informal experimentation. It's important to ask why experiment in the first place. Now, I could spend ages on this slide, but I'm not going to. There's lots of reasons to experiment, just to stay ahead of the curve, to improve your future career prospects, to increase both the breadth and depth of your skills. But yeah, there's lots of good reasons to experiment. My first journey into artificial intelligence started when Microsoft created these sites. Has this got a laser on it? Yes. I can see that. Could shoot people if they start talking. And these websites were amazing because you could upload an image of a dog and it would say what species of dog it was, or you could upload an image and it would say how old the people in that image was. And back then, 5-10 years ago, this was amazing. Everyone was like, wow, how does it know what species of dog this is? Fast forward to today, we could probably knock this up in an hour, any one of us in this crowd. So that's got what started me on this journey. And then when I went to learn how that worked, I stumbled upon this technology called ML.net from Microsoft. But it was really boring. It was how to detect cracks in grayscale images of tiles. This is probably really important if you're monitoring the integrity of the concrete around the Chernobyl nuclear plant, but I'm not. So I had to make it more interesting. And the code was sound, just I found it a bit boring. So I thought, what if I use cartoon characters? More specifically, what if I got a set of good cartoon characters and a set of bad cartoon characters, trained an image classification model, create my own neural network, and then gave it some more cartoon characters and that wasn't in the training data, and see if it could determine if they were good or bad. That's how I learn stuff. Got to make it fun and interesting to me. So once you've trained your neural network, and I won't go into all the details, basically Super Ted would go through the neural network and arrive out at the result of good, and Cruella de Vil would go through the neural network and end up with the result of bad by taking a different path through the neural network. And my first experiment was really successful. It had 100% accuracy with the first, well, few dozen that I tried. And it's a really weird feeling when you've done this for the first time, because it feels like you created your own type of intelligence, albeit a very, very narrow type of intelligence. But nonetheless, you have to marvel at what you've created. I won't go for that architecture slide, it's a bit boring. And then you can go try this out yourself at goodyorbaddy.com. The code's on GitHub if you want to pull it down and try it, or train your own data sets on different types of images. You can even determine which, there's a spoiler here if you've never seen Frozen 7,000 times like me, who's got 2 kids. Someone shaking the head, close your eyes. Oh, he is. There's the character in it that starts off good and ends off bad, and then the site manages to determine at a point in time whether they're good or bad. I thought that was a good use case. So the first takeaway is have fun, because you're more likely to learn something better and faster and remember it if you're having fun during that process, and that's just proven in schools. That's fact. I don't have any links to show you. And the second thing is, when you're learning something new, it's going to feel difficult and weird and uncomfortable. That is normal. If you are staying in your comfort zone and you're not learning new things, trying new things, and not getting uncomfortable, you're just not growing. So don't worry if you're trying new things and it's difficult, it just means you're growing, because discomfort equals growth. Then tried training the image classification model in the cloud and created a website called It's Christmas Tree, which would tell me if an image of a tree was a regular tree or a Christmas tree. You can check that out as well. And the next takeaway is show, don't tell. There's a lot of thought leadership at the moment with people saying the good things about AI, the bad things, but there's not much people actually showing you how it works, which I found really, really weird. So if you please show, don't tell. That's the way you're going to put your point across. But if you are just going to tell, just try and show as well. And then, again, this sounds very silly, I trained a naughty elf detector. If you've got kids like me, these will come back every December, whether you like them or not. But this time I decided to train the image classification model and see if I could use it in a real-time camera feed, rather than just static image analysis. And I don't know if we've got a sound for this next slide, but I found a sample that was trained to use a model that identified fruit. So I just swapped out the model for the one I trained online, and it works a bit like this. I don't know if we've got sound, we'll see. So no elf, no elf, no elf. Okay, so again, silly, but once that could be applied to very, very real world use cases. It just, once you've learned the theory, you can just apply it as you wish. My next takeaway is share, because it sounds trite, but I do believe that sharing is caring, and whenever you share, you are lowering the barrier of entry for someone else, and you do not need to be an expert to share what you've learned. A lot of people stop or don't want to share because they don't think they're an expert. I've written a book in augmented reality, I still don't think I'm an expert in it. Turns out writing a book is a really good way of learning something. The next artificial intelligence type of artificial intelligence I played around with, learning agents. Now, learning agents are really good if you know the results of what you want the software to do, but you don't want to tell it how to do it. That sounds really bad. So, for example, I wanted to know how these 2D car simulations learn how to navigate the course by themselves. So I went off and learned how to do that. And this is uses something called reinforcement learning, and this is both in a software term, but also in a psychology term, where we're encouraging good behavior by rewarding it and discouraging bad behavior by punishing it. And that is how Google created Agent 57, which was a deep learning, reinforcement learning agent that learned how to beat all 57 Atari 2600 games. All that it has is a very limited number of inputs, training the model, was given feedback whether they were getting further on in the game or less, and it managed to complete all 57 games. It doesn't know, or it wasn't explicitly told, right, you need to jump over that hole, you need to dodge that bullet. It just managed to work out the game based on the inputs and the feedback it was getting. So I found some code on GitHub that had this like simulation interface. I didn't write it myself, and it really boils down to creating random numbers for these neural network cars, because every single car's got a different like brain in this neural network, which means all these values here between these nodes have got different values, and which means when it gets closer to the different sides, left, right, forward, and diagonal, it will turn to different degrees away or towards the wall, some of them. So some of them will turn into the walls and crash immediately, others will turn away to varying degrees, but it's the cars that get the furthest that we're interested in. Just to prove that we're not explicitly telling it what to do, all that's in that network of neural nodes of inputs and outputs are these values here, and this is like the brain or the values of the possibly weighted activation function, are these values, and that's all it is in there. That's the brain of the car that managed to navigate the course over and over again. So we need to reward this fitness, and this person created the code that says fitness is a multiplication of the distance travelled and the time it took to do it as well, and how well it stayed in the middle of the course. And then what we do is we take the ones that did the best and like breed them with the other cars that did the best, a bit like the same ways that you get both genes from both your genetic parents. It took the best of both of the cars and then used that for future generations. So generation 1, the cars didn't get very far, they didn't make it around the first bend. By generation 32, they just about made it around the first bend. By generation 128, we have a car that's managed to go all the way around the course, and it would just go over and over around the course. Okay, so yeah, that's learning agents. That's quite fun to learn how to do. Again, if you don't know how to solve the problem, but you want your learning agents to figure out themselves, this is a really good approach. The next thing you want to do is see if it can, once it's learned how to navigate the old track, if it can navigate the new track, but I've not done that experiment yet. So the next takeaway is build out your tool belt for a couple of reasons. One, if you've only got one tool or one skill or one set of experiences, you're going to approach every single problem from the same perspective, and that's just dangerous. So the more tools you have at disposal, the better you'll be able to approach it. Ideally, you have lots of tools and lots of experience so that you can approach every different problem from different perspectives. The next, I wanted to work out if I could build a Wordle solving puzzle. I was inspired by one I saw that would solve Sudoku puzzles. So it would literally put the camera over the Sudoku puzzle, it would identify the grids and the squares, and do obstacle character recognition to work out the numbers, and then solve it. So I wanted to see if I could do that on my iPhone using Apple Vision OCR functionality, and managed to identify the squares, the colours in the squares, and I think everyone's played Wordle probably, or familiar with it hopefully. And then it would say which of the 5-letter words would match what you've already guessed, and make it a lot easier. That was a cool way of learning how to create Apple mobile apps. So the next takeaway is that implementation is so much more important than the idea. I'm not one of these people that says ideas are worthless, far from, but implementation is unfortunately just so much more important than the idea. Take it from someone who's almost completed a master's degree in entrepreneurship. If your ideas could be sound, but if you screw up the implementation, you're not going to deliver value. Next takeaway is keep it simple. So jumping in the deep end of a swimming pool isn't the best way of learning how to swim. If you're playing and experimenting, work out something works in the simplest way, and only then start making it more and more complex use cases. The next one is this phrase here. I hear it said a lot. We need to increase the art of the possible, or increase our knowledge of the art of the possible. And in my opinion, it's only through play and experimentation and learning can we only really increase our knowledge of the art of the possible. I'm also a big believer that we should be finding times and ways of experimenting and playing both at work and in play. So at work, if we can develop a culture that gives room and encourages play and work, we can encourage a culture of entrepreneurship And also in our personal lives, we've got things like hackathons, side projects, open source development, and online skill tutorials and stuff like that. And then the last artificial intelligence side project I want to share with you was something around generative AI, because that's become crazily popular over the last months, and I wanted to cut through the hype, going through LinkedIn again, lots of hype, but not much material of how to actually implement it. So I wanted to go off and work out how to implement it. So I created, this side project was actually finalist in the Worldwide AI Hackathon that was in September. What I wanted to do is create a website or a working prototype where you would select a destination, select how long you want it to go for, and select your interests. Create a sentence or a prompt, send that to OpenAI, and see if it could come back with some suggestions of things to do at those locations. Went through a few iterations, looked ugly to begin with, built up the functionality, worked out how to do it, brought in a map, brought in the latitude, longitude, hit another third-party provider to return the images, ended up with a site that actually looked like what you would expect on the web. It does work, because when I went on holiday to Madeira, I used the tool to suggest some places to visit. That's the Cristiano Ronaldo Museum, if you've never been there. So yeah, getting to the end of the talk now. So say use your imagination as much as you can, because it is like a muscle. If you don't practice using it, you will get worse at it. You just need to practice. This is why kids are so good at it. And scratch that itch. If it's something you want to learn how to do, and you've got something you want to learn how to do, just go ahead and scratch that itch. So just to summarize then, I'll go through this and we'll move on to the next speaker. Experiment, try new things, learn and grow. Don't stop daydreaming. Push the boundaries, because sometimes if we always do what we've always done, we'll always get what we've always got. So you need to push the boundaries, and that can be uncomfortable for both you and the business sometimes, but you do need to try and push those boundaries. Build out your tool belt so that you can approach problems with multiple different perspectives. Keep it simple, and then once you've learned the simple stuff, then you can start applying that knowledge and skills to a variety of different other use cases. Implementation is so much more important than idea. Share your learnings, because sharing is caring. Show, don't tell, or if you're going to tell, make sure you show as well. Don't reinvent the wheel. Try and stand on the shoulders of giants, reuse code that's come before you, and adapt it for your own needs. And use your imagination, as I've already said. And probably most importantly, have fun, because you are only going to succeed in what you're passionate about. If you're not passionate about something, not very much good chance you're going to succeed in it. So try and build in fun to anything you do. So that's the end of the talk. So just make sure you experiment, learn, and try new things. I'm on all the social medias, on LinkedIn, Twitter, etc. at Lee Englestone. So please reach out and contact me if you want. And that's it. I'm done, Chris.